So in this problem, we got a plane which is flying at an determined angle, which we are being asked, and it's throwing a missile from a 2.15 kilometer height and a 3.25 straight line from the point the missile is shot from the point the missile lands. So what we can obtain from here is basically a range, alright? So this range we're gonna obtain using the Pythagorean theorem. So we got 3.25 squared minus 2.15 squared, because as you can see this is a rectangle triangle. So if we want this part, then we just have to do the following, and this will leave us with a 2.47 kilometer range, which equals to 2,450 meters. Alright, with this information we can get started. So we're gonna solve the equation for x. We simply are gonna substitute our cinematic equations. Also, before we do this, it is important to note that the missile is being shot at a 280 meters per second speed. Alright, so by substituting in x, we got that the initial height, which equals the initial range, which equals 2,440 meters, equals an initial range, which is 0 plus 280 initial speed times the cosine of the angle, because we're talking in x, times t, which is the time. So in y, we got that the initial height, which is 2.15 kilometers, equals 0 plus 280 times sine of the angle, because we're talking in y, times the time, plus 1/2 of gravity plus time squared, as we already know from our cinematic equations. So what we need to do is solve time out of this equation and substitute in this equation, which is going to give us what is down here, which I'm going to explain in a while. So we got that time equals the 2,440 divided by 280 cosine of the angle. Alright, so by substituting this and this, we get the following. Alright, so what we really want here is an equation, a quadratic equation for the angle. So for this we got sine divided by cosine, which is going to give us a tangent, and in this case we got this term squared. Alright, so we got a trigonometric identity that says that 1 divided by cosine squared equals 1 plus tangent squared of the angle. This is a trigonometric identity. I'm just going to write it down over here. Cosine squared of the angle equals 1 plus tangent squared of the angle. Alright, so we got, by doing this and just solving everything, we can simplify, for example, these two terms, and we can simplify the gravity divided by 2, 4.905, and all this, and we get the following equation. As you can see, this is already starting to look like a like a quadratic equation. So then if we pass this subtracting and we solve this parenthesis, multiplying this by this and this by this, we get the following equation, which is tangent squared plus tangent plus an independent term. This looks already like a quadratic equation. So by solving this with our general formula, we can get two values, one negative and one positive. We know that the positive one equals the real one, and this one is 0. I'm just going to erase here so you can see. Tangent of the angle equals 0.66. And if we want the angle, we just have to do the inverse tangent to the -1, which equals an angle of 33.42 degrees. This is the angle that we're being asked for. By solving, I will just go really quickly over what we did. We get time out of this equation, substitute it in our equation for y, do the algebra, apply this trigonometric equation to get a quadratic equation, and then just solve for tangent, and then we get an angle of 33.42, which is the angle that is over here. Thank you.